Hello everyone, my name is Xinqi Chen. I'm from Yangzhou University. Welcome to my session. Today I'm going to present KVS, a tool for knowledge-driven vulnerability searching. The first one is I want to introduce you our objective. As you can see here is a set of CVE records from the official website. It has a name and the description. Somehow it's not that organized, and if we want to particularly analyze one CVE, it would be hard because we don't know other relation between this CVE and other CVEs. So what we do is we want to extract information from the description part, what's the most important entities in the description, and we connect each CVE vulnerability through the same information. So what we want to do is we want to construct a vulnerability knowledge graph based on the CVE records. The majority of my presentation would be introduce the overall construction process. As you can see, here is the reports contain summary, the unstructured test, and also the semi-structured test. We feed our unstructured test into our BERT model to perform the named entity recognition task. After that, we got our relation table and our entity table. As long as we have these two tables, we can store them in the graphic knowledge base or graphic database. It's Neo4j, maybe you know it. And after that, we visualize it in the front end. We divide our work into three parts. One is how we distinguish each entity in the summary. So we call it VNR part, and also the vulnerability storage part, along with the cage visualization part. So before we do the NER task, we need to prepare some data. I annotated 1,000 summary data in this format. For each particular entity, we define the category in it. And after that, we got 1,000 records in total. We divided 900 of them to training set and 100 to test. After we train our model, we have to predict. So our prediction set is 4,000. The next, we perform our NER task based on two models. One is BERT Softmax and one is BERT by LSTM CLF model. Unlike BERT Softmax, BERT by LSTM CLF model has one addition layer, which is CF layer. It has some correlations between output, and it has some restrictions for the output, so make output more reasonable and precise. So here is a result of two models. We list the different entities and the corresponding position recall FE of each entity. You can observe that the position or the overall result of BERT by LSTM CLF model performs better than the BERT Softmax. So we choose this model as our NER model to predict our final result, final table we want to obtain. So the next part is how we store the ball KG. So this comes into my mind, how we define the node and the relation in our knowledge graph. So basically, the source node is always the CVE ID, and the relationship is between CVE ID with the other entities. So like CVE and the cause. CVE is the source node, cause is the target node, and the relationship is also cause. So the target node is also the relation. It's simple. This schema is simple. And finally comes to our usage. This tool is available online. So this link, you can also obtain it in our paper. And this the main part of this tool is I visualize them in like a fabulous way. So you can search it, you can switch on what you want to. Yeah, and when you put your mouse into particular node, you can observe the information about it. No matter it's the extract information or the attributes it has. And the conclusion part would be the contribution of our work is we construct a NER task dedicated for the vulnerability domain. And the second is we perform two models based on the unstructured test. We compare each model's performance and choose one to prediction. And we build a vulnerability knowledge graph based on this. So the future work would be we can pipeline the construction process instead of manually doing each step. And we could increase the data scale. Well, here for now it's only 1,000 for the annotated data set. Maybe we could annotate it more either manually or use the machine translate, or you use other annotated schema. So the third one is we could explore more possibilities for practical usage. For now, it only has a searching. We want to make it more practical in the future. So that would be my whole presentation. If you have any questions, feel free to contact me. I know it's quite short time. Maybe you don't get the full picture. So if you have any questions, just feel free to contact me. Thank you again.